Hello, Math 30-1, welcome back. Today we're going to look at investigating the graphs of polynomial functions. So first off here, we're just going to do a quick review of what roots, zeros, and x-intercepts are. So as soon as we're talking about a function, we know automatically that we are talking about our zeros. Okay? When we're talking about a graph, it's going to be the x-intercepts. And when we are talking about an equation, we are talking about the roots of the equation. So now we are going to look at something called the unique factorization theorem. So the unique factorization theorem states that every polynomial function of degree n greater than 1 can be written as a product of leading coefficients of c and n in linear factors to get. So basically, how many factors we're going to get here is an n amount of factors. Okay, so there are 2 points this is breaking down into, 2 important points. Point 1 is every polynomial function can be written as a product of its factors and a leading coefficient. Point 2 is every polynomial function has the same number of factors as its degree. So every polynomial function has the same number of factors as its degree. The factors may be real or complex and may be repeated. Okay, so those are 2 very important points. All right, so here is our first example. So we're going to look at this polynomial function and its graph. So it's graphed right here. So first, let's state the zeros of the polynomial function. So my first zero here is going to be at -2. Okay? Then we have my second zero, which is right there, which is going to be at 1. Then finally, my third zero is going to be at 2. Now, what are the factors of these? Well, that's going to be x plus 2 is this one here. And we're going to have x minus 1 relating to this one. And this last one here is going to be x minus 2. Okay. Now it wants us to write each polynomial in factored form. Okay, so that's all we do. We're going to say the polynomial function of p of x is equal to x plus 2 multiplied by x minus 1 multiplied by x minus 2. Alright, and that's it. Then it says use graphing calculator to plug this into your graphing calculator, and just to double check to make sure that this graph looks like that. It's a way to double check and see if it works. Okay, now let's take a look at question number 2. Okay, it says use a graphing calculator to sketch the following equation. So I'm going to quickly plug this into my graphing calculator, turn it on, get into my y equals, and we are going to plug in this equation here. So we have negative bracket, and we want x to the power of 3, and we're going to plus 4x squared, and then we're going to plus 7x, and then we're going to subtract 10. Make sure right here we use our negative sign and not the subtraction sign. And we graph it. Okay, there is my graph. I could see my x-intercepts. I'm going to just zoom out of here a bit, change my window, go to maybe minus 15 and positive 15 for my y, so I could see it a little bit more. There we go. That's a little bit better. Okay, so we get something that looks like that. Can we change a bit more? Let's go to 25. There. So there we go. So there is my graph. Okay, now we graphed it there, but it wants us first to state the x-intercepts of our graph. So then to state the x-intercepts of my graph, just going to adjust this a bit here. I am going to a bit more. Show you what I do for my keystrokes. We're going to go second calculate, and we want to find my zeros. And we're going to go to the first one here, which is, we are left, then we go right of it, and then we're going to choose a guess in the middle, and I get -2. So my first x-intercept is at -2. Put that down there. Now we want to look at my next x-intercept. So I'm going to do the same thing again. We're going to calculate. We want a 0 because zeros are the same as x-intercepts. Left of it, there. We go right, there, and a guess somewhere in between. I'm going to end up getting 1. That's another one. And then we want my third x-intercept. Second, we're going to trace it, and we're going to find my 0. So that's number 2. Go all the way over, so we're left of the x-intercept, which is, well, too far, which is around there. Now we're going to go right of the x-intercept, there, and somewhere, I guess, in between, which is there. I get 5 as my last one. So these are my x-intercepts. Okay, so let's put these all onto my little graph here. So we're going to say -2 is around there, then we have 1, and then we have 5 over here. Okay, and my graph came down. It went like that, then up, and then back down like that. And that was my graph. So, write the polynomial in factored form. So, those are my zeros. So, my factored form is going to be p of x is equal to, we're going to have x plus 2, x subtract 1, and x minus 5 is my polynomial in factored form. Then it says circle the correct alternative. So the left arm of the graph is rising or falling. So left arm way over here, is it rising or falling? It is increasing on the left side. So this one here is going to be rising. Okay? Now it says the right arm of the graph, is it rising or falling? My right arm is down here, and this one here is falling. Okay, it's going down. Then the degree, is it even or odd? Well, we are degree 3, so it is odd. Then the leading coefficient, is it positive or negative? Well, I look at my leading coefficient, it's negative and negative. Okay? So, while you're doing this assignment, what's going to end up happening is, later on, is you're going to end up investigating the difference between what the negative coefficient means and what does the degree do and how the graph opens and closes and the direction it is. And you'll be doing that in your assignment when you start doing it here. Okay?